We are Group 5. Our project title is Control Unit with the topic of PS2 keyboard. Introduction. PS2 port was introduced in IBM's Personal System 2 personal computers. It is widely supported interface for a keyboard and a mouse to communicate with the host. The PS2 port contains two wires for communication purposes. One wire is for the data, which is transmitted in a serial stream. The other wire is for the clock information, which specify when the data is valid and can be retrieved. The information is transmitted as an 1-bit packet that contains a start bit, 8 data bits, an odd parity bit, and a stop bit. Whereas the basic format of the packet is identical for a keyboard and a mouse, the interpretation for the data bits is different.
For the background, PS2 or IBM Personal System 2 is an interface for keyboards to PC-compatible computer systems via 6-pin mini DIN connector. The computing system must provide the keyboard with 5-volt source and ground connections. Communication occurs over a 2-wire serial interface consisting of a clock line and a data line. Both lines required pull-up resistors. The 120 ohm series resistors are required to interface the 3.3 volts FPGA I/O to the 5 volt signals. Once powered, the keyboard goes through a self-initialization sequence. Upon completion, it is ready to communicate keyboard events over the PS2 interface.
Now let's move to PS2 keyboard scan code. A keyboard consists of a matrix of keys, and an embedded microcontroller monitors and scans the activities of the keys and sends scan code accordingly. There are 3 types of key activities that are observed. First is when a key is pressed, the make code of the key is transmitted. Then when a key is held down continuously, a condition known as a typematic, the make code is transmitted repeatedly at a specific rate. By default, a PS2 keyboard transmits the make code about 100 milliseconds after a key has been held down for 0.5 seconds. When a key is released, the break code of the key has been transmitted.
The diagram below is an example of the make code of the main part of the PS2 keyboard. It is normally 1 byte wide and represented by 2 hexadecimal numbers. For example, the make code of A key is 1C. This code can be conveyed by 1 packet when transmitted. The image below shows an 8 circles which represents LED. These LED are separated into 2 hexadecimal numbers. The first hexadecimal only consists of 1 on LED, while the second consists of 2 on LED. We can depict it into binary as 0001 and 1100. When converted into a decimal, it is 1 and 12, and when in hexadecimal, it is 1C. The table below shows the make code and break code of the keys. For example, in letter A, it has a make code of 1C. In letter B, it has a make code of 32. In letter C, there is a make code of 21, and so on and so forth.
This is the Verilog module for PS2 keyboard. So the communication between the keyboard and the controller uses 2 signals, the keyboard clock and the keyboard data. The data for each key that is sent over to the keyboard data line consists of 11 bits. These 11 bits are 0 for the start bit or the first bit, the 8 data bits for the key code starting with the least significant bit to the most significant bit, an add parity bit, and lastly 1 for the stop bit or the ending bit. So this is the simulation for PS2 keyboard. So When there is no activity, that is when there is no key pressed on the keyboard, both keyboard clock and keyboard data are at 1. When a key is pressed, the keyboard sends a unique code for that key to the controller serially over to data line. The serial data on the keyboard data line is synchronized between the keyboard and the controller by the clock pulses that keyboard sends over the keyboard clock line. Gaya nga po ng example kanina, when we press A, the PS2 keyboard sends a unique code. Tapos, i-represent yun ng LED na nakikita natin ngayon. So, kagaya po ng sabi kanina, this is the 2 hexadecimal. When we convert it, this is equal to 12 and this is equal to 1. So, if we convert it to hexadecimal, equal to sa 1C. So, if we go to the keyboard scan code table, 1C is equal to A. So, yung example kanina is tama. So, this is the technology schematic of the PS2 keyboard and the RTL schematic. So, as you can see here, we have another code for the PS2 keyboard, but this is the VHDL code for it. So, this is the 2 VHDL code.
In conclusion, this PS2 keyboard interface is a programmable logic component that receives transaction from PS2 keyboards. It synchronizes the clock's domain, debounces the input signals, performs error checking, and notifies the user logic when new codes from the keyboard are available on its parallel output bus. And that's all for our project presentation, and thank you for listening.